Okay. So I'm gonna share my screen. Swap that out.
Yeah, I can see it.
All right. Does that look like it? Some kind of PowerPoint presentation?
It does.
Okay.
Yes.
Looks good.
All right. So thanks again for having me. Folks, if I haven't met, I'm John Giskowski. I'm a planning consultant and do some work with the town of Portland and the land use office. I'm happy to help walk you through some of the mandatory training. Today I figured we'd talk a little bit about site plan reading, which is, something that land use commissioners in particular have to do a lot of and are not necessarily trained up from the beginning on what to look for and how to read a plan and what it means. It's a relatively small group, so feel free to jump in and ask questions, or I have some sort of interactive elements where I'd like some input from you folks as well. Um, and with apologies that I don't mean to condescend or go over basic stuff that you may know, but we just want to make sure everyone has a relatively decent baseline. Um, so a quick bit on maps versus plans. They're different things. Maps themselves show physical features of the natural environment at a fixed scale and orientation, north, south, east, west. But plans are what is to be done with the land, what is being proposed with how things are being adjusted and moved around on a map um, to represent potential development. And these things are not necessarily always the same thing. And maps aren't necessarily reliable indicators of what's really there. It depends on the quality of the map, the scale of the map, the resolution, as well as the date of the map. If you look here, there's two shots of New London. One is a USGS quad map that you can see the red and the blue developments on an aerial photo, but there's a whole area that's in orange on the right map that or on the right aerial that doesn't show up on the map at all. So why is that? It's most likely that's you're looking at an old map, and that the information that a map provides is very important, only in the context of the scale, quality, and date of the map that was provided. So it's always wise to check sort of multiple sources to kind of literally ground truth what a map is actually representing. And maps can tell you all kinds of stuff. The first question is, well, what the heck are we looking at? If you were presented with this site plan, what are we looking at? You would tell from basic context of what we're looking at here.
Not really. No.
And a lot of times it's I mean, it also might be the resolution of our screens or how much we're zoomed in. But this is an extremely busy map. A lot of lines, a lot of features. This is a site plan of a casino resort um, that is being proposed, not in Connecticut, but just an example of an extremely busy map. This shows a busy site plan, shows structures, shows driving, parking, circulation, utilities, um, and all sorts of amenities. But things can be extremely busy and crowded in maps, and it's very difficult to tell. On the other hand, what about this plan? What are we looking at? And
It
again,
looks like lot dimensions, some sort of boundaries on the right side of the map or right side of the plan.
so this is a lot line adjustment that was proposed in Willington. The map on the right side is sort of zoomed out parcel area. This map extends between Interstate 84 to the sort of north west. And if you sort of see the right here, can you guys? Oh, sorry. Can you guys see the cursor on the screen?
Yep.
Okay. So the north arrow is right here. So Interstate 84 over here is to the sort of the northwest. Ruby Road, which is State Route 320, is to sort of the southeast. Um, and it's focused on this property right here, zoomed in, which is the focus map on the left. Um, is basically a lot line adjustment for this parcel that spans it. But there's, you know, for a map that doesn't actually have a lot of lines on it, there is quite a bit of information to be presented. So what are we looking for on a map? So the things that we would look for to determine what it is that the plan is representing and what it's showing us are some of these elements: location, list of the drawings that are in the site plan set, orientation, which way is north, the title block, exactly what this is, what people are calling it. Is it a named development? Is it a specific geographic area? Legend, extremely important. The scale, and then very important for a lot of the applications we review, is the zoning table. And all of those things will help provide clues for what the heck is going on the map. So based on that, what is this cover sheet telling us for this proposed set of site plans?
So it's telling us the address.
Okay, so we're in Clinton, Connecticut.
Yeah. Oh, it looks like a list of the plans or maps.
Right.
Yeah.
And who created them, or the team that created.
Exactly.
When it was prepared
Yep, that's important.
and revised.
Mhm.
Um, And I guess the sheet index will tell you how many pages there are.
Correct. Good. So yeah, we know where this is. We know what this is for. So we see it's a planning and zoning application submission. When it was created, it was revised, who the project team is, who the property or project owner is. And again, at the sheet index, we're going to take a look at that. And the sheet index, you know, this is like a fat stack of pages. We have several pages of landscape plan, some enlargements, standard details, wetlands buffer, photometric plans. We know what to expect. And so that's provides some easy reference, particularly when, you know, you're reviewing a site plan together and an engineer, you know, calls out, okay, we need to look at, you know, page 2 of the wetlands enhancement plan. So we know exactly where we're going, what we're looking for. And that's all ideally in the cover sheet. So again, the title block, this gives us all of the basic data of what this is, who's it by, who's it for, when was it generated, when was it updated. And projects that don't have those things are generally problematic in some way. We are missing something important. In that plan set, okay, so we're using this project in Clinton that I was involved with several years back as kind of our example. We'll revisit the site plan several times. This is a landscaping plan. And again, it's not at a high enough resolution. It would be more helpful if we were together and had, you know, 24 by 36 plans to sort of lay out and look at. But in a landscape plan, what sort of elements would we be noting here?
Trees,
Right?
you know, bushes.
Trees, planting. So you see, if
Yeah.
you can see these the little circles all up and down the drive aisles here, the areas of shaded are probably planted, grassed, shrubs, maybe this sort of stippled
gravel?
building is probably sidewalk or pathway. What's really important in a plan like this is the legend. And so back up here, up in the upper right-hand corner, which is obviously you can't see very well, but we zoom in on the next screen, is the legend. And each of these, you know, the circles for the trees, and the different landscape features are given a key. And I'm not a landscape architect. I'm not much of a horticultural specialist, so I'm often like looking these things up, looking up what a you know, Blue Point juniper or a London plane tree or a greenspire linden is. But all of these things are called out and featured on the map. So if you see something on a plan that does not have a label on it, or the label does not correspond to something in the legend, that is not your fault. That is not a problem of your inability to read the plan. That is a problem of the plan not describing what is there, or what is proposed. But so that, very often these things can be extremely busy, but in a well-prepared site plan, each of these things will have some corresponding label that will help you with the legend understand visually and spatially where everything is being proposed. All right, so when we are faced with one of these massive plan sets, what are some of the first things we do to review? On the town side, it is very, very useful both for the town and for the applicants to work off of a checklist and to make sure that things are included. Everything that the town says it wants and everything that the applicant is providing should be as part of a checklist. So what sort of information do we need? Some towns do a physical checklist, either an online version or in association with a site plan. Say, here's your application form, here's a checklist to make sure that everything is being proposed. This example comes from the town of Mansfield, where they show the print size, the number of copies, the signature block, all of the names and addresses of all those things. This is taken from the town of Portland's zoning regulations. This is the first section. There's actually quite a few elements in the town of Portland's zoning regulations for site plans. So each of these things, the title block, location map, boundary survey, area, name of adjacent owners, where the stormwater system goes, where the sewer system goes, where the sidewalks go, drainage, stormwater detention, trees, stone walls, landscaping elements, buffer areas. And it goes on and on and on. Lighting, fire lanes, outside storage areas, provision for water supply, cut and fill calculations, the table of zoning compliance. All of these things, if you are going to be providing what is to be considered a complete site plan, all of these things need to be included on the plan, or that there for some reason is not applicable. So if there is no lighting proposed for some reason, if it's a park development or something like that, there might be no lighting plan necessary. That seems unlikely, kind of a bad example to have chosen. But let's say in number 26, there's no endangered species on the proposed area. Obviously, you're not showing that on the plan because it's not there.
Can you request waivers as well?
Yes. So waivers are allowed for application submission elements. The zoning commission would not be allowed to have a waiver of a zoning requirement. That's not part of the application, but say zoning requires 6 parking spaces per restaurant table or something like that. That's not waivable. That would require a variance. But on the application elements, if you don't, if you aren't doing any filling, you're just, working at grade or something like that, you wouldn't have to put in cut and fill calculations and you could get that waived, for instance. So yes, that is an ability of the commission to do that sort of waiver. And so ideally, and Dan, correct me if I'm wrong, but I don't think that the town has a current sort of checklist that gets distributed to applicants to kind of verify against. It's really just part of the staff review process, really, I would assume, right?
Yeah, and then we direct applicants to our regs
Right.
for site plans
Yeah.
and special permits.
So, I mean, we have a long list. It's not in checklist form, but it's essentially here are the things you need in your site plan. And this is the things that you as commissioners and we as staff will be looking at. And some of those very key things are scale, which is relative size. How much area are we actually depicting on this size map? It's we want the written scale and the delineated scale. So if it's a key map would show something like an inch equals 1,000 feet, which is a ratio of 1 to 12,000. But a graphical scale is the most useful because again, something could be drawn on a 24 by 36 site plan at 40 scale, 1 inch equals 40 feet, and then you reduce it to an 11 by 17 or an 8.5 by 11, or you just photocopy a section of it, and all of a sudden it's not to that scale. So if you put a ruler down on that piece of paper after it's been photocopied or enlarged or reduced or something like that, you're not going to get the correct calculations of how far apart things are because it's been distorted. So the most useful thing to look at, particularly if you're looking at a map that is not the original printed scale, take a look at the graphical scale so you can get a sense of, you can actually put a ruler on that. And if it's in this case, if you put that 2 inches, if that doesn't actually measure 5 inches and that's actually only 2.5 inches, well, you know that the math you need to do to get it to calculate to the right scale. Engineering scales are something that planning and zoning folks use quite a bit, and these traditionally represent the most frequent scales that we depict, because most of the time we're dealing with basically site plan scales, projects of several acres, but not town size, not quarter of an acre, tiny lot sort of thing. So 40 scale, 40 feet per inch is roughly a common site plan scale. And on a scale like that, or I have one here in my bag. I had one here in my bag. I'll stop sharing my screen for a second, so I can just illustrate this. I'm sure that you guys have seen these triangular scales, and each of them have, where's my camera? Up in the corner, you can see the 10. So this basically has 6 edges. It's got a 10 scale, so 1 inch equals 10 feet. It's got a double edge there, that's 20 scale. On the opposite side, you see the 40 scale. And so you basically would correspond the side you would use for an engineering scale like this based on whatever scale the drawing was drawn at. So this is shown up to scale. So what we're looking at here is a site plan with several buildings and a multifamily layout. So we have, house 23, house 24, which are duplex, and across the way from another house, maybe house 25. This is drawn at 40 scale. So you see that we're using the right distance here. We're using the 40 edge of the scale. So about how far distance are these 2 buildings? What's the gap in between the 2 buildings across the way?
That's a good question.
160.
Carolyn, go ahead. What do you got?
I just did 4 times 40, right?
No, so okay, so that's I see what you did there, but it's actually, so the reason that we have the different scales. So this recalibrates. So what you're looking at are not inches. This is not 1 inch, 2 inches, 3 inches, 4 inches. This is 40 scale. So this to the 4, the 0 to the 4, is actually your first inch. This is 40 feet.
Okay.
So so at 40 scale, there's 10 feet, 20 feet, 30 feet, 40 feet, 50 feet, 60
Yeah.
feet.
Yeah.
And again, so then, and if you want to, put that over like a standard ruler, your inch would basically come out to the 4 or the 40 feet.
Okay.
So,
Oh, I see. Okay. I guess I didn't. Okay.
and so then from the 0 out to, which is where the edge of the building 24, out to the edge over here, it's a little bit less. So, the distance from here to essentially to the wall of this other building, 25, let's call it, is about 60 feet.
60 feet.
People see what we did there?
I got it.
Yep, I got it now.
Yeah. I was thinking.
Yeah.
Yeah.
And so this is, I think it would probably be more useful if the 40, the numbers on the 40 scale said 20, 40, 60.
Yeah.
But that's
Yep.
what we're talking about.
Okay. Obviously, I didn't know that.
This is why we do these trainings. And you know, and a lot of times, you know, that you're also, you know, blessed to have, you know, professional staff that can kind of, you know, vet these things as well, town planner, town, you know, zoning officer, engineers. But yeah, it's good to verify these things for ourselves. Can we tell what scale this site plan is at?
Um, well, you could derive it, I guess, come up with some number, right?
Well,
Because you
in,
have it from
in
the
theory, I mean, you have a measurement here, 45 feet from the street.
Yeah.
However, what the dimension here on the you know sort of
Oh,
the
it's
is only
22.
22 feet. This
Yeah.
is called only 24 feet. Um, and then you have striped parking, which parking spaces are generally 10 feet by 20 feet. So, you know, we've got, several parking spaces here, presumably 10 feet apart, 45 feet. You know, if that's 45 feet, Smith Street itself is probably about 60 feet wide, which would make it, you know, the widest single road you've got in town. So this is why we use scale, because something like this will not give you sufficient
Yeah.
idea of circulation so a lot of times there could be a temptation or whatever to, if it's not a complicated project, that someone just sort of sketches it out. No, the shed's going to go over here or the building's going to go over here. Parking will be around it. Don't worry about it. That can be problematic, especially if you have to go back and determine if something was actually built the way it was supposed to be built. How the heck do we know if this was built, to plan? So there's a great deal of cost associated with coming up with a plan, to scale, with the topography, all these things in the right place. But we're in the business of safeguarding public health, safety, and welfare, and it's not too much to ask for someone to at least get their distances correct. Now that we all know how to scale out those distances themselves. So we're missing. I've sort of given away some of these things. We're missing a scale. We're missing direction. Which way is north?
Yeah.
Are we on the east side of Smith Street? Are we on the west side of Smith Street? Does Smith Street even run north south? All of these pieces of information. Is this a perfectly flat site? There's no grading. Nothing needs to be moved around. We're missing a lot of kind of important information here.
No landscaping. What are the lines on the right supposed to be depicting? More parking?
I would assume more parking. I mean,
Yeah.
that's another problem is we have no legend to know what the lines mean.
Yeah.
Yeah, I assume that's probably more parking.
Or the ruler you're supposed to use.
Well, there you go. There's your scale. That's the missing scale we were looking for.
Yeah.
Okay. And the other really critical element, particularly in planning and zoning applications or DBA applications, is to try to figure out how what is being proposed meets the regulations. And so this is, an application for a development of a flag lot, a rear lot as part of a subdivision. And so you see the different dimensional elements, what's required. It's basically a 40,000 square foot, like a 1 acre zone. And each of the properties, is meets that or exceeds it. Needs to have a minimum lot width, minimum frontage, setbacks for structures, a minimum buildable square, and minimum buildable areas. And so it basically, gives you a quick review, and it's upfront so that you're not having to look at the plan, flipping back through to the zoning regulations saying, geez, what is this setback supposed to be? Where can this building go? How big does this have to be? It's all upfront, and so you can see at quick reference how everything complies with the zoning regulations or does not. And in some cases, particularly if you're in the ZBA, they may be asking you for relief from one of those things, and you can see on the map what that means, what the setback reduction or the minimum size reduction means on the ground. Notes on the plans. These are extremely useful, particularly when you have questions about why is this here, or how is this map derived? Why were certain things selected here? This is a snippet from a planting plan that was pulled off of the corner of the landscape plan that we showed earlier, and shows things that shows order of planting, erosion control measures, who's responsible for these things, that that there's a call before you dig requirement, the contractor was responsible, trees, like references to trees along sidewalks, how those are handled. And on something like this, as part of a formal plan set, these are all legally binding. If the applicant submits this for planning and zoning, a special permit review, or this is part of a variance review, this is part of the formal record. This is part of the formal application. So each of these notes, insofar as they represent something that the applicant has to do or something that the applicant is responsible for, these are legally binding. So if they do not, if there is a problem with call before you dig, there is reference in here for whose fault that is and who is responsible for correcting those things. So these are all, part of the legal approval, part of the legally binding terms and conditions of the approach. All right, something else that's a major part of site plan revision or site plan review is topography, and exactly what's up, what's down, what's the slope, where do things drain in relation to other things. So the contours that you'll see on the topographic map is it's an imaginary line. It's sort of based on the elevation, and it connects areas of equal elevation. So you can tell on a map if you're going uphill, if you're going downhill, if you're flat, and where the slope is. So we're going to look at a couple of these examples. A cross section is sometimes, again, on a site plan, is used to represent those 3D objects in 2 dimensions. And so you see on the scale here, we're looking at elevations from 200 to 260. These are 10-foot contour lines. And so based on this, do the dots represent, does this dot over here represent a high point or a low point?
I would say a high point.
High point.
Right, because we're going from elevation, the base of this slope is at elevation 200, we're going up the hill 210, 220, 230, 240, and the top of that hill, the top of that little knob is at 252. And then it comes down over here, and the sort of saddle in between the 2 little knobs is at 225. It's at sort of a low point, and then it goes up the hill a little bit, back up to 2. So we have sort of a higher knob and a lower knob, and those contours represent, how that slope is proceeding. Contours will always connect with each other. Very frequently, when because a map is not infinite, it is not the entirety of the Earth, it has to cut off. So sometimes the contours will not connect within the map boundary, but they will always connect as part of some real topography, some real landscape.
So John, there must be a legend somewhere that defines how much the gap is between each contour line.
Well, that's why we need to do measurements. Because topography is, it's real life conditions. It's so we're looking at a site plan from overhead. We're looking at down from above, a 2-dimensional view of a 3-dimensional landscape. That's whatever scale it's drawn at. In the case of the previous map we looked at, that was 40 scale. So you can measure the distance between any 2 lines of contour using that same scale and determining. Well, that's what we're going to talk about right now, is determining the slope. So the slope, again, is the direction that's calculated perpendicular to the contour line. So contour is essentially, the round, concentric circles that we saw here, just show you it's you can picture them as sort of steps, but very rarely is something like a ziggurat or a stairway up to a pyramid, right? This is some like a gradual slope, and some are steeper than others, and some are flatter than others. And the way you calculate that and the direction of the slope is always perpendicular to the contour of the lines. So we have these contours in an S form, and the direction of the slope cuts across in a perpendicular way to that. So again, we have a slope here at the 14-foot contour, 12-foot, 10-foot, 8-foot contour. These are 2-foot lines in direction of the slope. This is the high point. We're coming straight down the hill this way, perpendicular again, the slope that way. And again, the slope, I mean, the land grades this way and in this S shape, but the slope comes straight down in a perpendicular way. So let's take a look at this. Let's assume that in each of these cases, the smaller circles on the inside are high points. That in each of these cases, the outer curves are the low points, and we're going up slope.
Okay.
So let's take a look at the silhouette for A here, the sort of camelback hill. Can you tell which of the numbers probably represents that contour?
Oh, for us, the bottom one, 6.
Number 3?
It's probably either 3 or 6. You're right. So
Yeah.
we have two mounds. So both 3 and 6 sort of have these two central peaks. The way we would sort of distinguish it is if you look at like the other camel hump here, D,
Right.
which is probably the other one. Let's take a look at kind of which one is steeper.
Yeah.
And so therefore, which one probably has more lines of contour versus sort of a gentle difference between the low point and the high point. If you see what I'm saying.
Yeah,
So if you look at 6,
6.
we have a number of contours that are relatively close together and stack up. That would indicate a steeper slope.
Right.
And 2 of those. So that represents A.
Okay.
D, on the other hand, we have sort of a fewer lines of contour, which means less difference between the low point and the high point,
So D.
and less difference. So it's sort of a gradual, downhill back to the uphill.
Mhm.
Less difference in between the two mounds. So that's A and D. What do we think about B?
B is
5.
1.
5, I
Oh.
think.
1.
Oh, no, I think it's
No,
1.
one, yeah.
One.
Are we
Oh,
okay?
okay.
1.
We're at 1. So the thing we see here is again the high point. So a lot of contour lines up to a single point up at the top, one peak, and there is a lower peak, a significantly lower peak, but there is another, area high point,
Yeah.
which is
Yeah.
represented there. The
Mhm.
other one that we looked at, 5, that the other one suggested, again, really sort of just has a single, it's sort of attenuated out this way, sort of a gradual wide slope that slopes off to the bottom, but a big, basically flat peak. If you look at the top
Yeah.
contour here,
Okay.
it's a relatively large area of flat. It's kind of a plateau. So which one would 5 represent?
F.
F.
Right, exactly.
Yeah.
And then similarly, sort of in the opposite way, C would be represented by which? That has a relatively small peak up here and then sort of a gradual attenuation, fewer lines
4.
off to the right. Correct, 4. And then the final one over here, E, is just
That
2.
right.
2.
So it's sort of a single peak in the middle, a lot of lines of
Yeah.
contour that indicate a pretty steep slope up to the top. Good. You got it right.
Yes.
Woo!
A bit of doing, but
You talk it through. It's good. Okay. So again, so we calculate the slope direction perpendicular to contour lines from obviously high point to low point. The highest contour number to the lowest contour number. But to Bob's question, how do we measure it? How do we know what the slope is? If you remember your high school geometry,
Hmm?
slope is
I
rise
had a
over
bad teacher.
Well, hopefully I'm not giving you flashbacks right now.
you know,
You're giving me
Yes,
bad
yes.
flashbacks.
Sorry.
in case he was a bad student.
So it's basically slope is the change in elevation between any 2 points over a given distance. So elevation again is the difference between those two contour numbers, the 14 and the 12, or the 12 and the 10, or the 10 and the 8. That's the elevation change, 2 feet at a time. And then the distance between them is something that we would measure on a scale with our 40 scale or whatever the drawing was drawn at. And then we would divide those numbers, and then there's your slope. So for instance, what we're looking at here is we have a slope. The low point here, let's call that elevation 20. And the upper part here where the guy in red is at elevation 30. So we have a vertical difference of 10 feet.
Mm-hmm.
And the horizontal distance from one contour line to the other is 20 feet. So we're picking up 10 feet of elevation over 20 feet of distance. 10 over 20 times 100, 50% slope. Is everyone relatively comfortable with that math?
I think so.
Is there going to be a test?
That's entirely up to Dan. I'm not going to give you a test.
Oh, okay, then no. Right, Dan?
There will be no tests.
Okay. Well, this will.
Well, I will comment, when we took Casio classes, this subject was one of the hardest portions for
Yeah.
people to pass. People really struggled with this in Casio, so
It's tough.
it
This
certainly-
is actually, Dan, this probably looks familiar. This is taken a lot from the stuff.
huh?
This probably looks familiar because a lot of this was taken from the Casio slide deck.
I'm not sure if they had PowerPoint when I took
Yeah.
Casio, John.
Okay, so the question then is, why do we care what the slope is? And we care because we live in Connecticut, and things wash downhill. We have water, we have snow, we have vehicles with inadequate emergency brakes. We have water in basements. So for health and safety, public welfare and safety, issues of erosion, issues of soil stability, slope is important. And so if you're facing a site plan with a tremendous amount of topography and they're proposing to throw in a soccer field or something like that, we know that there's going to be a lot of slope challenges. Again, and this is fairly basic. If a site is graded or proposed to be too flat, there's not any pitch to it at all, either naturally or in the proposed condition, you're going to get ponding. Stormwater is not going to go anywhere when it happens. And if it's at the bottom of a hill and you're not accounting for any subsurface drainage, it's going to flood. So, too much slope is bad. Not enough slope is bad, because things are either going to wash away or they're going to pond up. It was funny. Years ago, I went to a workshop about bike and pedestrian enhancements, and it was done by a road engineer. And he said, what are the 3 most important considerations when you design a road? There are 3. He gave us the first one. It was drainage. The second one started with a D.
Direction.
Nope.
Demolition.
Nope.
Hmm.
This is a trick. The second one was drainage also, and the third one is drainage also.
Oh,
When you're designing any kind of site that is going to be used by people, drainage.
Yeah.
And that's why slope calculations and understanding are so absolutely.
well, somebody didn't pay attention to that for Route 17A, Portland.
And some of those things. Well, I don't know how new that section of road is, but
Yeah,
a lot of times, roads settle over time, and drainage problems can arise that weren't necessarily originally intended. Okay, so I see we're already well into this, so we're gonna kind of buzz through some of these others. Typical site plans are going to contain a lot of these things. The cover sheet that we looked at, existing conditions plan is very important, so you know what is there now, and so you can get a sense of how are things being moved around, what's being removed, what's being added. Again, if you're looking at something that is replacing an existing building, it needs to have a demolition plan. How is that being addressed? And again, these are for, physical developments where you've got buildings and stormwater and sewer lines and water lines and power lines. You have utilities plan, the site plan itself, which shows you where the buildings and roads are in circulation, landscape plan for the plantings, detail sheets, for what the cross section of the road is going to look like, what light fixtures are looking like, what if there's a stormwater separator, what that looks like, curbing details, all of those things are in the plans, as well as drainage plans, erosion and sedimentation control, so that things are being sloped in a way that take care of stormwater, but don't negatively affect erosion or wash into the wetlands. And then building elevations and floor plans, depending on how complicated the project is. And
Hey, John.
all of these things, I'm sorry, go ahead, Bob.
Just a quick question. Does the
Yeah.
type of material on site show up somewhere in a plan?
The
Whether it's
type of material?
clay or
Yeah, it very, very often in an existing conditions plan, particularly for undeveloped properties, you would have soil types in many cases. And those soil types would affect the drainage plan. So even if you're doing drainage in infiltration underneath a parking lot or in a grassed area, the soil type is extremely important because that will affect your drainage. If you have a dense clay soil that doesn't drain well, it doesn't matter that it's an acre wide. If you're dumping all your stormwater on it, it's just going to stay there. It's not going to go into the soil. Or if you've got really nice sandy soils, they'll infiltrate fast and you don't necessarily need that much square footage to drain whatever area it is. So yeah, you will have those areas for drainage things. And in other ways, yeah, you'll have materials if it's, if you're doing a walking path, is it stone dust? Is it asphalt? Is it concrete? Is it those things would be detailed as well. And the plan set ideally will have a lot of these things on different sheets because a plan that includes everything that has drainage and ENS and utilities and site plan and landscape is going to be far, far too busy and complicated to be able to read. So that's why you tend to have multiple plan sets, just because there's so much going on in any layer. So let's look briefly through a couple of plan sets, and these are complicated. Again, this is for people who are familiar with Clinton. This is right across the street from the Clinton Crossing outlets. It was the old Morgan High School before they built the new one, maybe 7 or 8 years ago. It's basically a multi-building commercial plaza that's being developed. So this is the grading plan. What we see here, well, tell me some features that you can pick out based on the site here.
Landscaping.
Right. Okay. So we see some landscaping here, like
Mhm.
off to the well, first of all, let's take a look at the north arrow. Here's the north
Yeah.
arrow.
Yeah,
So due north is sort of off to the left side of the screen.
yep,
So this is, sort of the eastern side of the site is undeveloped. It's grassed and wooded. Yeah. And you do see some proposed landscape elements, trees down here. Okay. What else?
are these dotted lines the contour lines?
Yep. So these right here are contour lines. And you see also, so we see over here below the contour line, sort of sweeping in here, this is the limits of wetland. So the flagged lines here. And then, as you see the contour lines, it corresponds. So this is, here's a contour line, here's a contour line. There's a long distance in between these two,
Hmm.
which basically means it's flat. And that's
Yeah.
not surprising because that's essentially a wetland. Wetlands
Yeah.
areas tend to be pretty flat, poor drainage, not a lot of slope.
yeah.
Is it
Well,
a
you
40
see-
scale?
This is, yeah, if you can barely pick that out right here. You see the scale. This is drawn at
I
40
see a
scale.
legend.
Legend up here that tells us what all these things
Yeah.
are. So the little flag lines that I showed you with wetlands, that's the
Yeah.
wetland flags that are shown there.
What
Parking,
rev we're at?
What was that?
Are these revved up or anything like that?
Revved up?
Sorry, never mind.
I see parking,
Yep, we have parking aisles,
the buildings,
buildings. We have a very big multi-tenant building here. This is a big Y.
and I'm
Uh,
assuming those are kind of walkways or sidewalks.
Yep, so we have a large patio area here and sidewalk,
Mhm.
the sort of graded areas, the areas right around the buildings.
Now,
walking pathways.
it must show paved area versus grassy area, but I can't
Yeah.
pick it up.
Yeah, I
Yeah.
mean, that's tough at this with this resolution on the screen.
Yeah,
But yeah, each of the, and each of the paved areas would be called out and colored in.
Okay.
But so again, this is the grading plan, which basically shows us where things are going to be sloped and
Yeah.
and stormwater drainage too. So we saw a lot of those things. We saw the scale, we saw sheet numbers. Like if you look back in here, who this was done by,
yeah,
Fedis Engineering, it's the grading plan.
What- yeah,
We have the legend, a lot of the things that we talked about. There was a legend, so we found a lot of those things. This is a wider view of the full site. This is the overall landscape plan, and I think we saw this earlier.
mhm,
Well, we've got again multiple buildings. We have the landscape plantings description, a couple of the representative icons for the different shrubs, trees, shrubs, or other planting. And it gives us again another view. A lot of
yeah.
the view over here shows us drainage. It has some of the landscape details, particularly when it deals with the hardscape, things that are not going to drain, things that are going to be collected in the stormwater system.
Mhm.
And then this gives us, more information about the things that are going to be planted that are part of the visual environment.
Is this where isn't there a big Y there?
Yep,
or something?
this
Yeah.
large building is the big Y.
Yeah,
And I think they have these two buildings in place. It's been a while since I've been there. And then way down here on the south end of the site is a Starbucks
yeah,
that's
Yeah.
in place. And yeah, I think they're working on, getting tenants to fill the rest of these spaces.
yeah, I think it's pretty, I've been by there, I haven't been in there, but it looked like it was pretty filled up.
Yeah, they're coming along pretty well. Okay, so we looked at a lot of those things. This is the erosion sedimentation control plan, where a lot of the things that you'll see on the legend have, where the silt fence is going to go. Over here, does anyone know what this represents over here on the north end of the slide, right alongside Route 81?
Is that the flow of the traffic? No,
So here's 81. Here's one driveway. You see that way?
yeah,
There's a driveway up the middle here.
yeah,
Anyone? So we have some, these are contour lines.
right,
What is
And so
that, a
this is-
drainage
It's-
basin?
Very good. That's a
yeah,
drainage basin.
yeah,
So this is, it slopes down. There's a flat bottom to this drainage basin. And a lot of the stormwater will be piped here and will settle in and infiltrate in that basin right there. And it's got, pretty well steep sides there. And again, the scale and of the plan orientation may change on different sheets. So obviously here we're looking at half the site, and it's half the site on the same size sheet. So the scale here is different. This is at 40 scale. And if we looked at the previous one, that shows you the entire site, again, on the same size sheet. This is, I think, probably at 100 scale, or 80, yeah, I think this is probably at 100, but I can't read it. But so you're looking at the same site, the same details, but distances will matter because it's drawn at different scales.
Can I ask a question?
Of course.
How do you know that how do you read that basin as a depression rather than a convex surface?
Well, so if we zoomed way in, which I can't do in this thing, each of these, I don't know if you can see, right in here, there are little numbers that give you the contours.
Okay, I can't, but
Yeah. Right. It would be, it's there. Obviously, we can't see it at this scale, but that's the way you would tell. And in this case, it would also, if you know that to be a drainage basin, it wouldn't make sense to have this at the high point and have
Right.
anyway, but yeah, but that's, there would be contour numbers on there. Okay. And so then there's also, again, it's important to sort of get a ground truth of what's being proposed, particularly if you have a hard time looking at just a site plan, a lot of lines on paper, and sort of deciphering where things go. And so, GIS, aerial photography is a great way to kind of, convince yourself of what you're looking at. So this is that same site. Based on what we saw in those development site plans, does this aerial photo reflect that development or not?
Mm,
Nope.
So that's correct. This is the previous condition. This is,
Yeah.
an aerial photo taken maybe 10 years ago. This is Morgan High School before it was torn down. Over across the street, you can see Clinton Crossing. And it's oriented differently. This is, basically north-south as it would appear, on the globe view, with the Indian River to the east. And so that's, this does not reflect the map, in part because this is pre-demolition, and in part because this is basically rotated, 90 degrees from the site plan that we looked at.
Yeah.
So if you think of this, and I'll go back to the site plan. So picture this, if this is sort of I don't know, like a Santa Claus hat, stocking cap, like rotate it, down this way so that Route 81 is on the bottom of your screen.
Mm.
And we'll go back there.
Mm.
So the old high school is over here.
Right. Right.
A lot of this was just, ball fields and open space. And so that's what we're reflecting in the site plan.
Mm-hmm.
And we'll go back.
Mm-hmm.
So there we go. So now in this way, we are kind of rotating the site plan map to reflect more or less the real world conditions. So we rotated the site plan map so that Route 11 or Route 81 is here on the left. This is the northern part of the site. So this line right here, where I'm drawing, is basically the northern boundary of the site.
Yeah.
You can see the river, the river off to the east there. And so that and this is ideally a little bit closer to what we were talking about. So you can see the big Y in place
Mm.
Here, and then there's going to be a couple of buildings built out over here.
Mm.
Is the sort of the northern phase of that project. Does that, can you see how the aerial and sort of taking a look at the aerial versus the site plan kind of helps you work both sides of your brain on that. All right, last little bit is we'll just talk a little bit about drainage, because this is kind of an important thing, particularly I think on the planning and zoning end. The drainage lines are shown in sort of black and white dashed lines. You see what I'm tracing here?
Yeah.
There's sort of drainage lines over here, drainage lines over here.
Mhm.
And what we see is topographic lines. So we have the 33-foot contour here, 34-foot contour here, 35. So we're going slightly upslope as we go over to the west. And then low points out over here, 33. And then at each catch basin, which is sort of like a terminus or a junction of the drainage, we have the catch basin elevation. So this is at 32.75. Do you see that?
Yeah.
Down over here is 31.6. Do you see that? A low point.
Mm-hmm.
Up here is drainage at 35.5. And so we basically go, again, water runs downhill. So we pick up water at higher points and pipe it, pitching the drainage so that it slopes downward towards the low point. And again, so the catch basin down here is at 31.
Mm-hmm.
The catch basins up here are at about 35. So we're running this downhill,
Mm-hmm.
down slope, and it will drain out into the wetland area. So anytime you see the drainage, take a look at their various elevations, and you can kind of catch the direction of the proposed drainage based on keep going down slope, keep going down
Yeah.
slope. Okay, so we're right at about 7 o'clock. We can answer some questions. Obviously, that was a storming through the topic, but hopefully it gave you a little bit more awareness of how some of the site plan pieces fit together.
Yeah.
And I'll stop for a second, and we can reshare if anyone has specific questions.
My only comment is the only place I remember seeing the zone that the site plan is in was on that one. It was a checklist sheet or something like that. Where
Oh, yep.
is that really the only place that the actual zone would show?
Yeah, well, it depends. In that case, well, we didn't go through the entire plan set for the Clinton Crossing. You know, for the it was called Indian River Landing. We
Yeah.
just kind of cherry picked some. But I believe in that case there would have been maybe one or two. They probably had an overall site plan layout with a zoning table on it. It would have been probably just on one sheet. And in that case, we had done some work and we rezoned that whole area, that whole parcel. So it kind of had a custom zone written for it. So that wasn't, compliance wasn't a problem because we kind of wrote the regulation to the development. But yeah, but there would have been on the site plan sheet the zoning table. All right.
Well, this was very helpful. I'm glad we pay engineers to figure this stuff out for us.
Me too. Me too. I'm glad all I have to do is kind of explain it, not design it. All right. Well, I appreciate you guys taking the time. I really appreciate your continuing to volunteer as commissioners. That's an incredible service to the town, and it's no treat to have to be rewarded for your service by having to do training. But I appreciate that you're taking the time.
Well, thank you.
Thank you.
Thank you.
Thank you.
All right. Have
Thank
a
you,
good evening.
John.
Yep.
Thank you, everybody. I think that's it. If there's no other questions, we'll do one more training in the next couple weeks. And then we'll be all set for everybody for the next 2 years, and then we'll have this obviously for reference and for anybody else coming on. So thank you again, John, and thank you for everybody coming on.
All right. Have a good evening. Everyone.
Thank you.
Have a good night.
Thanks,
Thank
Dan.
you.
Good night,
Dan,
everybody.
before you
Bye.
leave,
Bye.
I got
Oh,
one
yeah,
question
go.
for you.
Sure, Rob.
When you send out the link for this video session, could you send out the prior links too? So
Oh,
just
yeah.
one email with all 3 links, so that way, because I was on the first one, but I missed the second one. So
Yeah,
that
yeah,
way, it'd be easier for everyone.
Yeah, that was always my intention. So I will probably, it's going to take me a few days to have IT put the third one together. And when I get that together, I'll send out all 3 links and a reminder to everyone that they need to do this. So I certainly will do that, Rob.
Cool beans. Thank you.
Same
Rob,
here,
have a
same
good-
here, Dan.
What was that?
Same here. To me.
Okay, yeah, absolutely. Yeah, I'm gonna send a to both commissions. I'll send it out to everybody.
Okay.
Thank you.
No
Thanks.
problem. See you.
Good night.
Bye, everybody.